Vibes of Cosmos, Book 1, page 75, about daylight, of course, on the Earth, which we all know that the Earth is not a spinning ball with curved water. How does daylight happen? Ionosphere, which is one of the layers of the atmosphere. The ionosphere is the upper portion of atmosphere and starts from 40 kilometers height onwards. Okay. There in the ionosphere, there are the inert gases, also called the noble gases. They are separated on layers according to their molecular mass because of their density. Okay, not gravity, but density. Very important, pure science. The sun happens in the ionosphere and makes circles over the flat Earth, but circles in the sense of analemma. Okay, so the actual movement of the sun is an analemma, but when it's put on paper or to interpret it, we see it as a circle. The sun is the pilot light, which is an electromagnetic field, electricity, magnetism. And due to this light, which is electromagnetic, there are shadows. It gives the direct light. Good. Sun creates and also moving, so the electromagnetic field is curved. The thing that curves is the light electromagnetic field around it, around the sun, that makes all the inert gases in the ionosphere around the sun to react being ionized, giving fluorescence. So what happens is that because the gases are always present, they get ionized. They react. They react with the electromagnetic source and force field of the sun. The electromagnetism reacts with the gases, and that gives them fluorescence, and that creates the light that we see in the sky with different colors. And it's because of the moving, curved electromagnetic field that interacts with the noble gases, and that is exactly the daylight. It happens in the ionosphere and called plasma as well. So it's called plasma. It is a circle moving light umbrella over the flat Earth made by ionized inert gases. That's what we call daylight, and it depends on the colors. So the colors we see in the sky at sunrise and sunset depends on the type of gas that reacts with the electromagnetic source of light of the sun. And that's the reason why we have blue during the day, and we have pink, and we have orange, and we have purple, and we have red, and less red, and yellow. It depends on the angle and the day, at the time of the day, and the wavelength. Daylight is gas discharged light in a huge scale. But daylight is gas discharged light in a huge scale in the sky. When the sun goes away, the temperature and the pressure are getting very low, and the gases are discharged. When the sun approaches, because the sun moves, the electromagnetic field ionizes the inert gases, and we have the daylight. So we have the interaction of the gases, which are always present, with the approaching electromagnetic field, and that creates the daylight and, of course, the colors. If something curves, is not the Earth, but the daylight. The electromagnetic field curves because it happens due to the pilot moving electromagnetic field that the sun creates. Of course, the sun is created as a focused electromagnetic energy from the black sun below, which comes through Hyperborea, just like the moon. And because of that electromagnetic energy, which gets reflected back from the sky, it interacts with the noble gases, and we have daylight. Very simple to understand. I hope you just understand the basic scientific, realistic principle. You know, this happens every single day of our lives for thousands and thousands of years. So yeah, see you in the next video.